Hi, good morning students. So we are discussing our chapter that is HCl, hydrochloric acid, and now we are doing its part, that reaction of hydrochloric acid with various compounds or the various things. The first thing is the reaction of HCl with ammonia, that is your NH3, it is given here. So always when the reaction is between ammonia and HCl, there are dense or thick white fumes of ammonium chloride are formed, as we already performed the experiment of that how you are going to detect the HCl gas, that is a detection of the HCl gas. That detection is done by the ammonia and the reaction between this ammonia and the HCl, and there is a formation of ammonium chloride, that is a solid substance, and always two gas combine to form a solid substance, and the thick white fumes are formed from this ammonium chloride, right? And the second is reaction with the metals. The reaction whenever there is a presence of an HCl acid and a reaction with the metals, always the metals which are present at the higher position in the reactivity series, so that the metal combine and there is a formation of this salt, plus the release of this hydrogen gas will occur. Always hydrogen gas is released out. For example, this calcium combines with 2HCl, it will give you CaCl2 plus H2 is released out. That magnesium is combined with 2HCl, it give you MgCl2, H2 is released out. The next one is your zinc plus 2HCl, it will give you ZnCl2 plus H2 is released out. So this is the process. The first one is with ammonia, dense white fumes of ammonium chloride are formed. The second is with the metal, always there is a formation of a salt and a hydrogen gas, always that are the formations. Okay, moving on to the next reaction part, that is our next topic is the action on oxides and hydroxides. So whenever there is a action of that HCl on the oxides and the hydroxides, always there is a formation of salt as well as water molecule, and the salt which is formed here is nothing, just your chlorides, that is your, we are as called as metal chlorides are formed always. Okay, so when MgO is connecting with this HCl, there is a formation of MgCl2 plus water molecule. ZnO, zinc oxide, is connecting with 2HCl, there is a formation of ZnCl2 plus water molecule. FeO is connecting with HCl, formation of FeCl2 plus water molecule. Now Fe2O3, that is the ferric oxide, is connecting with 6HCl molecules, formation of FeCl3 plus 3H2O molecules. And then CuO is connecting with 2HCl, formation of CuCl2 plus water molecule. And this, if the hydroxides are present, as the hydroxides are combined, these are the hydroxide which are combining with your HCl molecule, then the formation of NaCl plus water, that is calcium hydroxide with HCl, there is a formation of calcium chloride plus water molecule. Always the formation of metal chlorides plus a water molecule is present, that the water molecules are also formed along with them. So this is the action of acid chlorides on the, that is acetic hydrochloric acid on the metal oxides and metal hydroxides. I hope it is clear. So now next is the reaction with metallic carbonates, that is the metallic carbonates are given, and the bicarbonates here. So in the metal carbonates or the bicarbonates plus with the hydrochloric acid, there is a formation of metal chlorides plus water plus carbon dioxide, right? There is always formation of metal chlorides, water plus carbon dioxides. For the first example is about the carbonate, that is sodium carbonate is reacting with the HCl molecule. There is a formation of a NaCl, that is our metal chloride, sodium chloride, water molecule plus CO2. When calcium carbonate is combining with HCl molecule, there is a formation of calcium chlorides, water plus CO2 gas. Then if the bicarbonates of both the things, the calcium and water, sodium are there, and they are reacting with the HCl molecules, always the formation of a metal chloride, the same compound, water and CO2 gas will occur. So always remember, while you are performing any of the reaction, just to emphasize on the part that your reaction must be balanced. So please keep this thing in your mind, that your reaction must be a balanced reaction. Otherwise, if you wrote a right reaction, then no mark will be provided to you. Okay, your reaction must be a balanced reaction is there, that the balancing of the reaction must, that the must part is there. Okay, clear? I hope that is fine. So the next reaction is about its sulfides and the reaction with the sulfides. Okay, let's do the next part. So next is the reaction with metal sulfides. Whenever the reaction of your metallic sulfide with your HCl, always remember this thing, the HCl is taken as your dilute HCl. There is a formation of metallic chlorides plus a H2S gas is released out. Please remember this thing, beta. Whenever there is a reaction of metal sulfide, then always there is a formation of metal chlorides. With this metal chlorides, this HCl gas is released out, that the HCl gas is releasing out. So the examples are given as, if we have a sodium sulfide, then with the reaction of this HCl, always formation of NaCl, that is a sodium chloride, with the release of this H2S gas, and as well as when there is a reaction between this FES with 2 HCl molecule, then the formation of FeCl2 and H2S gas is released out. Though that hydrogen sulfide gas is released out, this hydrogen sulfide gas is released out when there is a reaction between metallic sulfides along with your HCl that is taken as dilute. But whenever I talk about a reaction between the metal sulfides and metal bisulfides, then what happened to that? Then there is a formation of your metallic sulfide with the HCl, that is again taken as a diluted one, metal chlorides plus water plus SO2. So there is a formation of metal chlorides plus water plus SO2. So we have a metallic sulfide, that is your sodium sulfide with HCl molecule, formation of NaCl, water plus SO2 gas. And this potassium sulfide, there is the formation of again KCl, that is the potassium chloride, water as well as SO2 gas. So if we have a sodium bicarbonate, sodium bisulfate, or either we have a sodium hydrogen sulfide, okay, then there is a reaction between the HCl and the sodium hydrogen sulfide molecule, and formation of NaCl, water and SO2 gas will occur. Though these formations can be occur when there is a reaction between them. So remember one thing always, there is a presence of lead sulfate that is insoluble in the dilute hydrochloric acid, so its chloride cannot be repaired by adding the hydrochloric acid in the dilute form, because with that case we always requires a concentrated HCl for the lead sulfate, perfectly for the lead sulfate. And the best part about this both the reactions is that in both the reactions gases are coming out, and if in both the reactions gases are coming out, it means the brisk effervescences are coming out in your part, the effervescences are there by your part, so that effervescences will show you that the gases are coming out in a reaction in the liquid. So this is the reaction. So your next reaction is your about precipitation reaction, and in the precipitation reaction only the two compounds are there. The first one is your lead nitrate. Lead nitrate is reacting with the HCl molecule and the formation of a white PPT of PbCl2 and HNO3 is released out. The next reaction is with your AgNO3, that is silver nitrate. With the silver nitrate, HCl will give you a curdy white PPT of AgCl, that is your silver chloride, as well as release of your nitric acid there. So the thing is that that AgCl, that is the 3rd white PPT, are undissolved in this HNO3. They are not dissolving in this HNO3 part. Actually, that AgCl PPTs are dissolved in your ammonium hydroxide, that is NH4OH. They are dissolved there, and after dissolving in the ammonium hydroxide, there is a formation of a complex which is known as AgNH3 whole twice 1 positive plus Cl negative is along with it. So that compound is formed when this that silver chloride is combining with ammonium hydroxide, that they get dissolved with each other and the formation of the new complex will occur. So this is all about the reaction part of this the compound, that is with your nitrates, or with your precipitation reaction, that is with your reaction with the metals, metal oxides, metal hydroxide, sulfides, carbonates, bicarbonates, carbonates or bisulfites. So these are the type of reactions present with them. So you have your book, please go and read completely the whole chapter from your book also. Please do go on the test for the hydrogen chloride and the hydrochloric acid also, that some tests are given how you are going to the hydrogen chloride and hydrochloric acid. So that HCl gas that is present with you along to that HCl gas is to be possesses a irritating smell. That is the irritating smell is present with this HCl gas. So we can go on this irritating smell also to detect your HCl gas, that HCl gas is detected by that. The second thing is about the HCl gas for its detection, that is for its test part. When this HCl gas is combined with your ammonium hydroxide, we know this thing that further there is a formation of ammonium chloride. That ammonium chloride is containing your thick or dense white color fumes, and that white color thick dense fumes gives you an approach towards the HCl gas. Yes, the HCl gas is present, that is also the test part. When there is a reaction between this AgNO3 and your silver HCl, then there is a formation of AgCl, that is your Kurdi white PPT are formed along with your HNO3. So that white PPT are insoluble in the nitric acid, but they are soluble in the ammonium hydroxide. That white color PPT remains insoluble in the nitric acid, but they are soluble in your ammonium hydroxide. So that is the main reaction there, which is not given by any other acid or any other compound. The next is when there is a reaction between the manganese oxide, that is the plus HCl, then there is a formation of MnCl2 along with two water molecules along with a chlorine gas, right? So a greenish yellow gas, that is chlorine, is liberated when concentrated hydrochloric acid is treated with an oxidizing agent like your manganese dioxide. That is your manganese dioxide, it is reacting with HCl, that is in your concentrated from and then is a formation of MnCl2 water and Cl2. That Cl2 gas that you already know from your class 11, that it is a greenish yellow colored gas. That greenish yellow colored gas gives you the gives you an attendance towards the this HCl, that yes, there is a presence of that HCl. So we are just doing some tests to detect about this HCl, and yes, that greenish gas, that yellow colored gas or greenish gas will turns the moist iodide starch paper into a blue black. That color changes from your blue to black, that is the blue black color is obtained on that part. Okay, I hope that is fine now. This is done from here. So please do perform all the questions given in your notebook, in your book, as well as all the past year questions also from this chapter. So do well perform all the chapters. Okay, so see you in the next video.